Alright, we need to write the equation of a circle if given its center and a point on the circle. So if you read this example, what is the equation of a circle whose center is at 4, negative 2, and negative 8, 3 is a point on that circle? So let's put the points on the graph. I placed A and C on the graph, but what's weird about this is if I was to draw the circle, it would be well off the graph, just like this. And there's really no need to draw the circle that big, because we really just need the distance between the point A and the center point, because if we know that, that's the radius of the circle. So now that we know that, I'm going to draw in the line segment that's between point A and point C very roughly. Not a really good sketch. One more thing about this drawing. If you remember from yesterday, if we want to come up with the equation to this circle, you have to realize that we want to get the center of the circle right back to the origin. So how far we have to go in the x direction and the y direction, and in which direction, is going to determine the first two parts of our equation. So I think that's the easy part of this equation. So what we need to do, let's write them out. We need the x squared plus the y squared. We don't know the radius squared, so I'm just going to keep it as r for now. But in the x direction, we have to move it back. Let's get my little pointer tool. This one right here. Oh, there it is. We have to move it back 4 places this way, and then 2 places up in the y. So it's going to be a negative 4 and a positive 2 in the y. That's going to get us back to the origin. So in x it's minus 4, and in y it's plus 2. The radius is technically the hard part of this problem, because you have to figure out how long the line segment is from A to C, because that would be the radius of the circle. You can use the distance formula, or you can use Pythagorean theorem. I think I'm going to use the distance formula because more people are going to struggle with that, but I'm going to draw the triangle so that you can see it. So I added some legs to that right triangle, and to find the length of AC, you just have to count this distance from A, well, the vertical part is 5, and the other part is 12. So if you just did 5 squared plus 12 squared equals your hypotenuse squared, or we'll call it the r squared here because it is the radius, you should be able to determine what the radius length is. But I'm going to use our points and the distance formula to show that we can also get the same value of what we would have calculated with the Pythagorean theorem. So I'm going to use those 2 points as x. I'm going to use point C as my x1, y1, and point A as my negative 8, 3. So x2 minus x1 will be negative 8 minus 4 squared, and y2 minus y1 is going to be 3 minus negative 2 squared. Evaluating this, you get negative 12 squared plus 5 squared, and already you should be able to see that we have a 12 squared and a 5 squared, just like we do here. A negative 12 squared should still come out to be 144, just like a positive 12 squared will. So this is 144, 25. You're adding those. You're still taking the square root of that. So let's go over to here. We have the square root of 169, which then becomes 13. So now our equation was x minus 4 squared plus y plus 2 squared, and since the radius is 13 and r squared would have to go here, we would square that 13, and what do you know, we end up with 169. The exact number that was already underneath the radical before. And it's what you would have gotten up here if you did 25 plus 144. So that's it. That's how you find the equation of a circle if you're given a center point and a point that's on its circle.